So let's do a couple more of these more advanced problems. And like I mentioned, they're all fairly similar. So for this one, we have a product of these two exponential expressions. So let me just rewrite it. We have 2 root x multiplied by 4x to the minus 5 halves. And like the previous problem, we can treat the number factors and the variable factors differently. Or we can treat them one at a time. So we can do 2 times 4. Since multiplication, you can change the order. We can really put the 4 in front, and that wouldn't affect anything, since we know that 2 times 4 is the same as 4 times 2. Changing the order in multiplication does not change the result. And of course, 2 times 4 is just 8. And we're going to rewrite this square root of x using fractional exponents. So this is really x to the 1/2 power, since we're taking the second root, and x is really just raised to the first power since we don't see a number there. Now, we also have this x to the minus 5 halves, and since we are multiplying these two expressions, they have the same base, we are going to add the exponents. So we have 8 times x to the 1/2 plus negative 5 halves, or just minus 5 halves. And we can simplify that. 1 minus 5 is negative 4. So we get 8 times x to the minus 4 halves, and minus 4 over 2 is just negative 2. So this becomes 8 times x to the minus 2. And again, that's the form that we're looking for. So this will be our final answer. Let's just do one more problem. And again, this is similar, but a little bit challenging, since we're taking this exponential expression and raising it to some power. So one property that we definitely need is that when we take an exponential expression and raise it to a power, that we're just going to be multiplying these powers. But another property that we'll need is that when we have a product of, let's say, x times y, and we raise that to a power, let's say to the a power, that this is x to the a times y to the a. So in some sense, this power distributes to both factors in this product here. And this might make more sense if you have a specific example. So let's look at one where, let's say we have 2 times 3, and we're going to raise that to the, let's say, 4th power. So we're multiplying this expression here, 2 times 3, 4 different times. So let's just rewrite that, 2 times 3, and we'll do that 4 times. And what you can notice is that you're multiplying 2 4 times, and you're multiplying 3 4 times. So we could rewrite this as 2 to the 4th times 3 to the 4th. And this property holds in general, that when you have a product raised to an exponent, each factor of this product is also raised to that exponent. So with this in mind, let's use these properties to further analyze this problem here. So we have 27 times by the cubed root of z squared, and we're raising that to the 1/3 power. Now, let's first simplify this radical expression and change it to a fractional exponent. So we have 27 times, this is z squared, so z to the 2nd power, our numerator is the power we raise it to, and the denominator is the root we take. So this is just z to the 2/3 power, and everything is raised to the 1/3 power. Now we have a product here, so just like this general rule here, or this specific example, and we're raising it to some power. And so each of these factors, the 27 and the z to the 2/3, each of these will be raised to the 1/3 power. So let's work through that. This is equal to 27 to the 1/3 power multiplied by z to the 2/3, and again raised to the 1/3 power. Now, 27 to the 1/3, we're just looking at the cubed root of 27, which is going to be a whole number. That's just 3, since 3 multiplied by itself 3 times does give you 27. And here we have an exponent to an exponent, so we're going to have to multiply these. So we have to look at what 2/3 times 1/3 would be equal to. And of course, we just multiply straight across. 2 times 1 is 2. 3 times 3 is 9. So this would simplify to z to the 2/9 power. And just simplifying it as far as we can go, the cube root of 27, like we mentioned, is 3. So we have 3 times z to the 2/9 power. And this is the form we're looking for. So this would be our final answer.